This is on page 97 when we are done. So I'm doing this kind of out of order. I mean, there's not really a right order, just the order that it was like I originally had it in, because I felt like doing it sooner would have just confused things with the unit circle. But I feel like by now we understand the unit circle, we understand how to look at the quadrants, we understand all that stuff. We can figure out our values, God willing. But this is not our special angles. This is for any angle, and so it's important that what you connect to this is that this is not the unit circle. So we are still using some of the, like the quadrant stuff works, some of the same concepts. And the reason I'm having you put that is because here's where the confusion I find comes in sometimes. We've been saying, well, sine is y, cosine is x. Like, we know that. But the reason that sine is y and cosine is x is because the radius is 1, because we're talking about a unit circle. So when it's not a unit circle, it's not just straight up y and x, because it's not over 1, because that 1 changes, right? So if the radius is not 1, you can't just say sine is y and cosine is x. Okay, and that's what we're looking at here, is what happens when it's not a unit circle, when it's not pi thirds, when it's not an angle we know. What are we going to do about that then? Okay, so it says let theta be an angle in standard form, standard position. So here's this point P, x, y. So there's some point on the coordinate plane. And here's theta, right? It's on the terminal side of theta. And we get this little triangle right here, right? So here's our little triangle. And we know the distance from P to the origin is r. It's the radius. And then here's our little angle, little reference angle. So we know then, obviously, that this is our x value and this is our y value, right? Because r is not 1, sine is not just y, cosine is not just x. Instead, what we know from SOHCAHTOA, sine, opposite over hypotenuse, it's y over r, right? I totally skipped ahead of myself, but we'll go ahead and write that down. Let me back up a minute, I didn't finish this. It says we can find r by, and then it says Pythagorean theorem. Obviously, we can just set this up as x squared plus y squared equals r squared. And that's actually the equation of a circle centered at the origin, plus it's just Pythagorean theorem because it's a right triangle. But again, sine is y over r because the radius is not 1. And then that means cosine is x over r. Tangent, still sine over cosine, and it's still y over x. Because when you actually set that up, the r's are going to cancel out. We just don't need to go through that. That means that cosecant then is what? R over y. And secant is r over x. And cotangent is x over y. Okay? Everybody okay with that? Good enough? All right, so let's look at number 1. It says we have this point, 9, negative 12. It's a point on the terminal side of theta in standard form. Find the exact values of the trig functions of theta. So we need to draw a picture. So here's our coordinate plane. This point 9, negative 12 is in which quadrant? The 4th, okay? So we just go 9, negative 12. We're not making hash marks and counting. You're just like plopping it over there in something that looks like it could be right and drawing that in. Okay. Since the point is at 9, negative 12, this is 9, this is negative 12. And then I need to find the radius. Well, how do I find that? Pythagorean theorem, yeah. So 9 squared plus negative 12 squared equals r squared. So it's going to be 81 plus 144 equals r squared. So what's 81 plus 144? 225. Which means that r is equal to 15. So then when you go to do this, one of the things that, well, I mean, this is not that this isn't difficult at all, but one of the things that gets messed up the most are the signs on the numbers. So I would suggest that you write, I'm like picking the wrong number off, actually write out that x equals 9, y equals negative 12, and r equals 15. Because, you know, looking at your own handwriting wrong or not being able to read your picture or whatever, like that's the list of stuff you need to set all of these things up. Okay? So sine is going to be y over r. So this is negative 12 over 15. What does that reduce to? Negative 4 over 5. Cosine x over r 9 over 15. That reduces to 3 over 5. Tangent, y over x, negative 12 over 9, negative 4/3. Cosecant would be what? Negative 5, r over y, yes, and negative 5/4. Then secant would be 5/3. And cotangent would be negative 3/4. Okay. We good? Easy enough? Yes. All right. So let's look at number 2. Number 2, what quadrant is this going to be in? The third. I'm going to go negative 6, negative 2. It's like right there. This is negative 6. This is negative 2. So negative 2 squared plus negative 6 squared equals r squared. So that's 4 plus 36. So r squared equals 40. R is the square root of 40, which is 2 square root of 10. And is r, should I worry about the plus or minus here? Is the radius ever going to be negative? No. Radius is always going to be positive because it's a length. The x and the y could change the sign. The signs could change on those. But all right, so what I have here then, I have x is negative 6, y is negative 2, and r is 2 square root of 10. So y over r. This is negative 2 over 2 square root of 10. So the 2's are going to cancel out. That leaves me with 1 over the square root of 10, which becomes negative what? Square root of 10 over 10. Cosine negative 6 over 2 square root of 10. So that'll reduce to negative 3 over the square root of 10, which means that's 3 square root of 10 over 10, and just make sure that you're not losing your negative signs when they're there. Tangent, y over x, so that's negative 2 over negative 6, which is 1/3. Okay, so then cosecant is the reciprocal of sine. So what's that going to be? Yeah, negative square root of 10. Secant is the reciprocal of cosine. So this is going to be negative what? Square root of 10 over 3. And cotangent will be 3. What questions do you have? We're all good? Not really harder, just different. Okay, so the top and the back, this is definitely a review because, again, I'm kind of doing things out of order. So we've already talked about this stuff, and we get it. We're just going to talk, we'll write it down again. So this says that depending on the location of the terminal side of the angle, trigonometric functions can be positive or negative. Using your knowledge of the trig function values, identify the functions in each quadrant. Okay, so I want to know, when are these positive? In quadrant 1, what's positive? All of them. They're all positive, right? In quadrant 2, what's positive? Sine. Sine and what? Yeah, cosecant. I mean, we could just think of, for the reciprocals, I always take it back to sine, cosine, and tangent. I think if secant, cosecant, or cotangent come up, I say, okay, well, cosecant. Well, that goes with sine. And then I know everything about sine, so you want to make sure you can keep those connected. So quadrant 3, what's positive? Tangent or cotangent. And quadrant 4 would be cosine or secant. Okay? And that's where your all students take calculus comes from. Right? All right. And it says, remember this phrase. Okay. 3 through 6. This is all business too, but we're just going to zip through this. So if cosine is positive, cosine theta is greater than 0. That means it's positive. Which quadrants could the terminal side lie in? So when is cosine positive? 1 and 4. 1 and 4. Right? Tangent is less than 0, so it's negative. When is tangent negative? 2, and 4. So if secant's negative, secant makes me think of what? Cosine. And so cosine less than 0, that means it's negative. That would be what? 2 and 3. And now number 6 has 2 things. So when this happens, I usually draw myself a little, this so I can mark these things. So it says sine is less than 0. So when sine is negative, sine can be negative in 3 and 4, right? Cotangent is positive. Tangent is positive is 1 and 3. That means they overlap here, so it's quadrant 3. Does that make sense? The little dots help me, so otherwise I'll lose track of what I'm thinking in my head. It's just quadrant 3. Okay, what questions do you have? We good? All right. Let's look at number 8. So number 8 says cotangent of theta is equal to -4 and secant is greater than 0. All right, so again, cotangent, I'm going to, in my mind, really think about tangent. So if cotangent is -4, what's tangent? -1/4. Okay? And I'm going to draw a picture again, but I got to figure out what quadrant I'm in. Because not only is tangent negative, but secant, which is also what? Cosine, is positive. So tangent is negative in which quadrants? 2 and 3. So here's where tangent's negative. Where is cosine positive? 4 and 1, right? So we overlap here. That means that my picture is going in quadrant 4. That's a decision you have to make. Otherwise, you can't get all your numbers right. So I am in quadrant 4. So here is this. And then since tangent is -1/4, that's opposite over adjacent. So this is 1, this is 4, and then I have to decide which one of those is negative. The 1, because I'm in quadrant 4, right? If I didn't know what quadrant I was in, I wouldn't know which one of those would be negative. Then I need to find the radius. So now that you have it drawn and labeled, it's just like the stuff we did on the front. So -1 squared plus 4 squared equals r squared. So that's going to give me 17. R is the square root of 17. So x is equal to 4. Y is equal to -1. R is the square root of 17. Everybody okay with that? Then we just got to go and fill them in. Sine y over r. So this is -1 over the square root of 17, which is really negative square root of 17 over 17. Good. Cosine 4 over the square root of 17. So that's 4 square root of 17 over 17. Tangent -1/4. Okay. Cosecant goes with sine, so this is going to be negative square root of 17. And secant goes with cosine, so this is square root of 17 over 4. So in the fourth quadrant where we are, cosine and secant are positive. Everything else is negative. And that's what should be happening over here. Sine is negative, cosine positive, tangent negative, cosecant negative. I mean, those match up. Those work every time. Okay, we good? All right, so let's look at I want you to look at number 9. I want you to decide what quadrant you think it's going to be in. What do we think? Third? Good. So cosecant, I would write it down as sine, okay, or at least think it in my head. And there's no need to rationalize right here because it's not like it's my final answer. It's just me trying to figure things out. So sine is negative in 3 and 4. Cosine is negative in 2 and 3, so we're in the third quadrant. So I draw in my triangle, right? And sine is opposite over hypotenuse, so this is 2 and this is the square root of 5. Which one's negative? The 2, right? And then I have to find my x value. And so I've got to do x squared plus -2 squared equals the square root of 5 squared. So x squared plus 4 equals, what's the square root of 5 squared? 5. Yay, finally. After all these years. Okay, x squared equals 1. So what does x equal? Negative 1. Technically, when we solve it, it's plus or minus 1, right? I mean, that's what you actually get, is plus or minus 1 here. But here, this is negative because I'm in the third quadrant, so I do need to use negative 1. So again, this is not difficult, but it's easy to mess up on the signs, so just pay attention to what you're doing on those things. Okay, so now I have that x is negative 1, y is negative 2, r is the square root of 5. Yes, the radius is always positive. All right, we good? Where'd I lose you? Yes, sine is whatever. All right, so you go ahead and fill in the rest of those while I hand out the assignments, and then we will see if we agree. That's what I got. When you're done, double check yourself with me. Ask questions if you have questions. If not, then you can go ahead and put that in your ISN.